Captain Vasily Novosyolov stands on the bridge of the Soviet frigate Bezavetny at 09:54 local time, 11 kilometers from the Soviet coast, watching the gray slab of USS Yorktown carve through the Black Sea at 12 knots. The American cruiser is 10,000 tons of Aegis radar and missile cells, 3 times the mass of his Krivak-class frigate. 8 minutes ago, Admiral Chernavin transmitted an order with no precedent: curb the American ships without using weapons. Novosyolov has 8 minutes left to execute, and the only tool he has is momentum. His frigate was built for missile engagements, not collisions. The bow plating is 12 millimeters amidships, 8 millimeters forward, optimized for speed. Yorktown's hull is 19 millimeters of HY-80 steel, reinforced to carry the weight of America's most advanced air defense system. If he misjudges the angle or the speed, his bow crumples and his sonar dome floods. USS Yorktown entered the Black Sea on February 11, 1988, under Operation Caron, the U.S. Navy's program to challenge Soviet territorial water claims. The Soviet Union claimed 12 nautical miles of territorial sea off the Crimean coast. The United States recognized only 3, citing international law. Innocent passage doctrine permitted transit through disputed waters, but required strict compliance. Continuous forward motion, no surveying, no loitering, no weapon systems activated beyond self-defense readiness. The Ticonderoga-class cruiser carried the Aegis combat system, 4 fixed phased array radars capable of tracking 200 contacts simultaneously, and 96 vertical launch cells loaded with standard surface-to-air missiles. But for the transit to remain innocent under international law, Yorktown had to behave like a cargo freighter. Straight track, constant speed, no deviation. The Navigator aboard Yorktown plots a track that keeps the cruiser in continuous forward motion at 12 knots. Innocent passage prohibits stopping, anchoring, surveying, or deviating from a direct route through the claimed 6-mile Soviet zone. Every course change must be justifiable as navigation around hazards, not evasion of Soviet harassment. The Navigator marks waypoints on the chart, each one a straight-line segment that threads between shoals and keeps the ship at least 6 nautical miles from the nearest headland. The track is logged electronically and transmitted back to 6th Fleet headquarters in real time so that any deviation becomes part of the diplomatic record. If Yorktown turns to avoid a Soviet vessel, Moscow can argue the transit was not innocent. If the ship stops, the passage ends and the legal justification collapses. Soviet frigate Bezavetny shadows Yorktown from 300 meters, matching speed and course with its twin Zarya gas turbines spooled to maintain station. The Krivak-class frigate carries 4 SSN-14 anti-submarine missiles, a twin 76mm gun mount forward, and a complement of torpedoes. But none of these weapons can be employed without triggering an international incident. Instead, the frigate's role is to monitor, to crowd, to signal Soviet displeasure through proximity. The helmsman watches the cruiser's wake and adjusts throttle in small increments to hold the gap steady. On the bridge, the officer of the watch logs Yorktown's course and speed every 10 minutes, transmitting the data back to Black Sea Fleet headquarters in Sevastopol. The frigate's sonar dome, a fiberglass fairing below the waterline, sweeps the acoustic field ahead, listening for American submarines that might be trailing the surface task group. On the morning of February 12th, Admiral Chernavin in Moscow transmits a directive to Black Sea Fleet Command: curb the American ships without using weapons. The order arrives as a single-line encrypted message, offering no clarification on method, no threshold for acceptable force, no contingency if the operation fails. Fleet Command relays the directive to Bezavetny at 0940 local time. Captain Novosyolov reads the message twice, then looks out at Yorktown's gray bulk, cutting through the water 11 kilometers from the Crimean coast. The word curb is not a standard naval term. It does not appear in engagement doctrine, in harassment procedures, or in rules of encounter. Novosyolov has 20 minutes to interpret it, and the only tool that fits the constraint is the ship itself. Previous freedom of navigation transits had triggered Soviet harassment, but none of it had worked. Badger bombers made low passes over American decks, turboprop engines roaring at 300 feet, close enough to see the pilots' faces. Searchlights illuminated bridges at night, washing out night vision and forcing lookouts to turn away. Radio warnings filled guard frequencies with demands to alter course, each one ignored under standing orders. The US Navy logged every incident, photographed every flyby, and continued the transits. By early 1988, Operation Caron had challenged Soviet territorial claims 17 times without a single course deviation. Chernavin's directive implicitly acknowledged that symbolic harassment had failed. If the Americans would not turn for a bomber or a searchlight, they would have to be physically stopped. Bezavetny's hull plating was optimized for speed and missile payload, not structural impact. Amidships, the steel is 12 millimeters thick. At the bow, where hydrodynamic loads are lower, it tapers to 8 millimeters. The Krivak-class design traded armor for gas turbine power, achieving 32 knots in calm seas and the range to patrol the entire Black Sea on a single fuel load. The thin plating kept displacement down to 3,200 tons, allowing the frigate to carry 4 large anti-submarine missiles and maintain a crew of 194 without sacrificing speed. But steel that thin buckles under concentrated load. A collision transfers energy perpendicular to the plate, exactly the loading condition the design minimized. Novosyolov knows that if he misjudges the impact angle, the bow will fold inward, and the forward compartment will flood faster than damage control can respond. Yorktown's Ticonderoga-class hull uses thicker HY80 steel, 19 millimeters at the waterline, chosen for its high yield strength and resistance to blast loading. The hull frames are reinforced to support the weight of the Aegis system. 4 fixed phased array radar panels, each weighing 28 tons, mounted on the superstructure. Below decks, vertical launch cells are clustered forward and aft, each one a steel tube designed to contain the exhaust plume of a missile launch without rupturing adjacent structures. The combination of mass and reinforced framing gives Yorktown a decisive advantage in collision energy absorption. Where Bezavetny's thin plates will yield into form, the cruiser's hull will distribute impact force across multiple bulkheads and keel frames. For Yorktown's crew, the greater danger is not structural failure, but the political consequence of appearing to provoke the collision by maneuvering toward the frigate. The frigate's sonar dome, mounted forward below the waterline, is a vulnerable fiberglass fairing that houses the bow-mounted transducer array. The dome is shaped to minimize hydrodynamic drag and acoustic self-noise, but it offers no structural strength. A direct impact on the bow would compress the dome against the hull, severing the transducer cables and flooding the fairing cavity. Loss of the sonar array would leave Bezavetny deaf to submarine contacts, unable to detect American attack boats that might be trailing the surface group. Even if the hull itself does not breach, flooding the forward compartment shifts the center of buoyancy forward, increasing bow-down trim and making the ship harder to control in rough seas. Damage control doctrine calls for immediate counter-flooding aft to restore trim, but that reduces reserve buoyancy and limits the ship's ability to survive additional damage. No Soviet doctrine exists for deliberate peacetime ramming. Damage control teams train for missile hits and torpedo flooding, scenarios in which the enemy weapon dictates the location and magnitude of the breach. Collision drills prepare crews for accidental contact during replenishment or maneuvering in crowded waters, where both vessels are attempting to avoid impact. But ramming introduces a new variable. The collision is intentional. The target is a friendly ship, operating under rules that prohibit armed response, and the political objective requires the event to be witnessed and documented without appearing reckless. Novosyolov has no checklist for this, no lesson plan from the Naval Academy, no after-action report from a previous captain. He must estimate the impact force, the angle of approach, and the acceptable threshold of damage, all while maintaining the appearance of control. At 09:58, Novosyolov orders the helm to close to 50 meters and match Yorktown's speed within 1 knot. Too fast, and the momentum differential crushes Bezavetny's starboard side, rolling the frigate toward the cruiser and risking capsize. Too slow, and the collision reads as accidental, undermining the political message Chernavin demanded. The helmsman advances throttles to bring both Zarya gas turbines to 80% power, watching the digital speed readout climb from 11.2 knots to 12.0. The frigate's bow creeps forward relative to Yorktown's midships, closing the lateral gap from 300 meters to 100, then to 50. The target is the cruiser's starboard quarter, aft of the superstructure where the hull curves outward and will distribute impact over a larger area rather than concentrating it on a single frame. On Yorktown's bridge, the officer of the deck reports Bezevetny's course change. The Soviet frigate has closed from 300 meters to 100 and is accelerating toward the cruiser's starboard side. The Navigator calculates that any turn to evade will take Yorktown off its straight-line track and void innocent passage under international law. The track log, transmitted in real time to 6th Fleet headquarters, records every heading change. A turn now would appear as a deviation from the planned route, giving Moscow legal justification to argue the transit was not innocent. The commanding officer listens to the report and checks the radar repeater, which shows Bezevetny's bearing steady, range decreasing. He acknowledges the navigator's calculation and orders, steady as she goes. Doctrine prioritizes mission completion over collision avoidance when the other vessel is the aggressor. Bezevetny closes to 50 meters, close enough that Yorktown's crew can see individual sailors on the frigate's bridge. The helmsman aboard the Soviet ship makes micro-adjustments to rudder angle, holding the frigate parallel to the cruiser's track while reducing the lateral offset. The gas turbines hum at 80%, propeller cavitation audible as a low throb through the hull. The frigate's bow wave merges with Yorktown's stern wake, white water churning between the two hulls. On Bezevetny's foredeck, a sailor secures a loose hatch cover, unaware that in 90 seconds the bow beneath him will buckle inward. The collision alarm has not sounded because the approach is deliberate, not an emergency. Novosyolov watches the closing geometry and mentally rehearses the next order. Helm 15 degrees to starboard, timed to bring the port side bow plate into contact with Yorktown's quarter. Yorktown's commanding officer orders, "Steady as she goes." The helmsman acknowledges and holds the rudder amidships, maintaining the cruiser's 12-knot track along the pre-planned route. The order is logged in the deck watch log with a timestamp, 10:01 local time. The officer of the deck repeats the order over the intercom to Combat Information Center, where the tactical action officer monitors the frigate's approach on the Aegis radar display. No weapon systems are activated. The vertical launch cells remain in standby mode, their outer hatches closed. The decision to hold course is both tactical and legal. Turning now would concede Soviet authority over the disputed waters and validate ramming as an effective deterrent. Holding course preserves the innocent passage claim and forces the Soviet captain to accept full responsibility for the collision. At 10:02 local time, Bezevetny's portside bow plate makes contact with Yorktown's starboard hull. The frigate's 8mm steel meets the cruiser's 19mm HY-80 plating at a closure rate estimated between 1 and 2 knots. Metal grinds against metal, the sound a low, scraping roar audible on both bridges. The collision lasts 8 seconds as both ships maintain forward speed, the frigate's bow dragging along the cruiser's flank. Paint and outer coating peel away in long strips. Yorktown's hull shows no measurable deformation, the impact energy dissipating into the larger mass and reinforced frame. Aboard Bezevetny, the bow plate begins to buckle inward, the thin steel yielding under perpendicular load. The helmsman feels the shudder through the deck and checks the engine instruments. Both turbines remain online, propeller shafts aligned. Impact force equals the mass difference times relative velocity. Bezevetny's 3,200 tons at 2 knots of closure delivers approximately 140 kilonewtons of force perpendicular to its own bow plate. That force concentrates along a 2-meter vertical seam where the portside plate meets the keel frame. The 8mm steel yields before Yorktown's heavier structure, buckling inward rather than transmitting the load aft through the frigate's frame. Yorktown, with 3 times the mass and nearly twice the hull thickness, absorbs the impact as distributed pressure across multiple bulkheads. The cruiser's HY-80 steel, chosen for its high yield strength, remains within elastic limits. No permanent deformation occurs. For the frigate, the collision is a localized structural failure. For the cruiser, it is a scrape. The frigate's 8mm bow plating buckles inward 15 centimeters along a 2-meter vertical seam. The keel frame below the sonar dome absorbs the bending moment, deflecting but not fracturing. Steel frames are designed to carry axial loads from propulsion and hydrodynamic pressure, not perpendicular impact. But the collision occurs slowly enough that the frame can redistribute stress before yielding. The sonar dome fairing, a fiberglass shell mounted forward of the keel, compresses against the hull and cracks along its attachment points. Transducer cables running through the dome to the bow-mounted array sever at the deformed hull penetration, cutting power to the sonar system. The damage control alarm triggers automatically when pressure sensors detect the fairing crack, and watertight doors forward of the sonar compartment close under spring tension. Yorktown's 19mm HY-80 steel scrapes paint and outer coating along a 5-meter length, but shows no measurable deformation. The cruiser's hull is designed to absorb blast loading from near-miss explosions. A slow-speed collision with a lighter vessel generates far less stress than a missile impact. The impact energy distributes across multiple bulkheads and longitudinal stiffeners, each one tied into the keel and framing that supports the Aegis radar arrays above. Paint peels away in long strips, exposing bare steel underneath, but the hull plates remain flush with their neighbors and no welds crack. Damage control teams below decks report no flooding, no structural noise, and no deviation in compartment pressure readings. For Yorktown, the collision is a maintenance issue, not a casualty. Both ships' propulsion plans remain online. No shaft misalignment, no turbine trip, no loss of steering control. Bezevetny's twin Zoria gas turbines continue to deliver power to the propeller shafts, and the helmsman reports normal throttle response. Yorktown's 4 LM2500 gas turbines, mounted amidships in separate compartments, felt the collision only as a mild vibration. No alarms triggered, no automatic shutdowns occurred. But the frigate's sonar display goes dark. The bow-mounted transducer array, now disconnected by severed cables, stops transmitting acoustic pulses. The sonar operator switches to auxiliary mode, attempting to reroute power through backup cabling, but the damage to the dome fairing has flooded the cable conduit with seawater. Bezevetny is deaf to submarine contacts, unable to detect or track submerged threats. Damage control teams aboard Bezevetny report seepage around the sonar dome fairing, but no free surface water in the forward compartment. The cracked fiberglass allows seawater to enter the cable conduit and the dome's internal cavity, but the watertight bulkhead behind the dome holds. Seepage rates are measured in liters per minute, manageable with portable pumps, rather than requiring emergency dewatering. The forward compartment remains pressurized and habitable. Crew continue to monitor the damage, but do not evacuate. The collision alarm, which triggered automatically when the fairing cracked, is silenced after 30 seconds, once the damage control officer confirms the bulkhead is secure. The frigate's reserve buoyancy is reduced slightly by the water in the dome cavity, but trim remains within acceptable limits and the ship does not list. For 30 seconds after separation, both bridges are silent. Novosyolov watches the bow for signs of progressive flooding, checking the waterline for changes in draft or list. The frigate's bow sits slightly lower than before impact, but the difference is measured in centimeters, not meters. On Yorktown, the captain scans the horizon for the escorting destroyer USS Caron, whose 5-inch gun is trained on Bezevetny. Standard rules of engagement authorize defensive fire if the Soviet frigate maneuvers to ram again, but the cruiser's captain must decide whether the first collision was aggression or the end of the message. The Tactical Action Officer in Combat Information Center reports Bezevetny holding station, speed matched, no turn toward Yorktown. The silence breaks when the damage control chief aboard the frigate reports bow deformation stable and no water ingress beyond seepage. Novosyolov elects to maintain station rather than withdraw. The decision signals to Moscow that the ramming achieved its objective without crippling the ship. Withdrawing now would suggest the frigate is combat ineffective, undermining the demonstration of resolve that Chernavin demanded. The helmsman receives the order to hold course and speed, matching Yorktown's 12-knot track at 300 meters distance. The damaged bow is visible to every sailor on deck, a clear indentation in the portside plating, but the ship remains underway under its own power. The message is unmistakable. The Soviet Navy can and will physically stop American ships that challenge territorial claims, and it can absorb the damage required to do so. Novosyolov reports the collision and the hold station decision to Black Sea Fleet Command via encrypted channel. Yorktown's officer of the deck requests permission to alter course and open distance from the damaged frigate. The captain denies the request. Turning now would concede the point and validate Soviet use of ramming as a deterrent to innocent passage operations. The cruiser must complete the transit as planned, maintaining the straight-line track that defines innocent passage under international law. The Navigator confirms the ship is still on the pre-planned route. The collision caused no deviation in heading or speed. The deck watch log records the captain's decision with a timestamp: 10:03 local time, 1 minute after impact. The tactical action officer advises that USS Caron remains in visual contact, ready to intervene if Bezavetny maneuvers aggressively again, but standing orders prohibit offensive action unless Yorktown is directly threatened with weapons. Admiral Chernavin monitors the event via secure channel and orders no further contact unless the American ship deviates from its track. The directive confirms the ramming was demonstration, not prelude to engagement. Moscow received the message it intended to send. Soviet territorial waters will be defended physically, not just rhetorically. But escalating to a second ramming or to weapons fire would risk a shooting incident that neither superpower wants. Chernavin's order reaches Novosyolov at 10:15 local time, 13 minutes after impact. The captain acknowledges and relays the guidance to his bridge crew. Shadow the cruiser, but do not close again. The frigate continues parallel track, damaged bow a visible reminder of the collision, while Yorktown maintains its 12-knot transit toward the western exit of the disputed zone. Both ships continue parallel track for another 40 minutes until Yorktown exits the disputed zone. The cruiser maintains 12 knots, sonar and radar fully operational, Aegis system tracking contacts across 200 nautical miles. Bezavetny holds station 300 meters abeam, bow visibly deformed but underway under its own power. Sonar offline, but propulsion and steering intact. Sailors on both decks watch each other across the gap, some taking photographs, others simply standing watch. The collision becomes a shared experience, witnessed by both crews, documented by both navies, and transmitted to capitals within the hour. At 10:42 local time, Yorktown crosses the western boundary of the 6-mile Soviet claim and enters international waters. Bezavetny turns northeast towards Sevastopol. The mission complete. Bezavetny returns to Sevastopol under its own power. Shipyard assessment reveals 15 centimeters of permanent bow deformation, severed sonar cables, and stress cracks in 2 keel frames. The damage is serious but repairable. No compartments flooded, no structural members fractured beyond welding limits. Repair takes 11 days in dry dock. Welders cut away the buckled bow plating and fabricate replacement sections, matching the original 8mm thickness. Sonar transducer cables are rerouted through new conduits, and the fiberglass dome fairing is replaced with a reinforced version. Stress cracks in the keel frames are ground out and filled with high-strength welds, then X-rayed to confirm structural integrity. The frigate returns to operational status on February 23rd, 12 days after the collision, and resumes patrol duties in the Black Sea. Yorktown completes the transit with 5 meters of scraped paint and minor deck coating damage. No compartment flooding, no personnel injury, and Aegis radar fully operational throughout the incident. The cruiser's damage control teams inspect every frame and bulkhead along the starboard side and find no cracks, no deformation, and no change in compartment pressure. The scraped section is repainted in port, a routine maintenance task completed in 2 days. The The collision adds no downtime to the ship's operational schedule. Yorktown remains on station in the Mediterranean, conducting exercises and port visits as planned. The only lasting evidence is the deck log entry and the photographs taken by crew, which become part of the official incident report transmitted to Washington. The collision makes international headlines within hours. Moscow releases photographs of Bezovetny's damaged bow as proof of American aggression, framing the incident as a deliberate provocation that forced Soviet defensive action. Washington publishes Yorktown's track log, demonstrating lawful, innocent passage through disputed waters, and arguing the ramming was unprovoked harassment. The competing narratives play out in the United Nations and in bilateral diplomatic channels, each side citing international law and prior precedent. The incident becomes a test case for innocent passage doctrine, with legal scholars debating whether the Soviet Union's use of physical force was justified under the right to protect territorial waters, or whether it violated freedom of navigation principles enshrined in the Law of the Sea Convention. 6 months later, the United States and Soviet Union signed the Agreement on Prevention of Dangerous Military Activities. The accord establishes formal procedures for innocent passage notification, requiring advanced communication of transit routes through disputed waters, and prohibiting deliberate ramming as a harassment tactic. Both navies commit to using radio warnings and visual signals rather than physical contact to express objections to transits. The agreement includes provisions for post-incident investigation and establishes a direct communication channel between fleet commanders to resolve disputes before they escalate. The Black Sea bumping is cited explicitly in the preamble as the incident that demonstrated the need for clear rules. The accord does not resolve the underlying territorial dispute, but it removes ramming from the menu of acceptable responses. The Black Sea bumping becomes the last instance of peacetime ramming between Cold War surface combatants. The tactic proved viable as political theater, delivering a message that words and flyovers could not. But the diplomatic and structural cost made it unsustainable. Both navies recognized that repeating the collision risked catastrophic failure, either from structural collapse or from miscalculation triggering armed response. By 1990, both the US Navy and Soviet Navy added ramming response to damage control curriculum, training crews to manage flooding and maintain propulsion after deliberate collision. The incident remains a case study in operational constraint, how to enforce territorial claims without starting a war, and how to absorb a hit without conceding the point.